Bismillahirrahmanirrahim. Good afternoon, everyone. Today, in our lecture, we will try to solve some questions related with circuit analysis. Here at the first example, we have two independent voltage source, number one Vs, number two Vg. At the same time, we have three different amounts of resistance. Like we're seeing here, Vs, I1, I2, I3, and here we will see a voltage drop. No, sorry, here we will dealing with voltage drop. Here we will dealing with voltage drop because it's well through from the resistance. Here the VG will be the same. And here we'll come back R2. After that, R3 and plus R2 will equal R1 again to come back at the same amount. That's mean here, this example, I take this example from Turkish source. Here, the author wanted from us solve this circuit by calculate all of these different results of current. We will start by using the Kirchhoff current law, Allahu Akbar. I1 equal I2 plus I3. That's mean I1 minus I2 minus R3 equals 0. This will be the first equation to us. And after that, we will go directly to apply the Kirchhoff voltage law by calculate the V total to loop 1, let's say C1, and to loop 2 after that. By using Ohm law, let's try to calculate the equation on all of these currents. Here, let's start from I1. From Ohm law, V equal current voltage. That's mean the current here equal the different potential between A and B divided on R1. VA minus VB divided on R1. Here, the voltage drop at resistance 2. Current number 2 will equal the voltage drop at resistance 2. That's mean VB minus VC divided on R2. Here. And the last resistance is R3. And I3 will equal VBD divided on R3. Let's say this D node is the reference point. That's mean the potential at this point will equal 0 because we will start from this node and will end our circuit, our moving or current moving will end at this point because that we don't have any different potential. That's mean VD equals 0. Like I said before, we will put all of these results at the first one here, I1 plus I2 plus I3 equals 0. Yes. By that, we will try to calculate VB. VB equal equation 2.11. Now let's put all the known elements inside equation 2.11. All of the resistance, the Vs equal 14 volt, Vg equal 5 volts. Let's calculate Vb equal 8 volts. Now let's calculate I1 equal Vs 14 volt minus 8 divided on 3 equal to ampere, I1. Now I2 VB minus VG divided on R2, that's mean equal 1 ampere, I3 2 ampere. And by that we can calculate the voltage at all of the we can calculate all the voltage drops at the circuits. For example, here, VBD will equal what? And we can calculate the voltage drop at VAB and VBC. And after that, we can calculate the power because all of these two results, the current and voltage, are known. The power equal the voltage dot the current. But the author didn't ask all of this. Let's go to the question number 2. Here, question number 2 will be different because here we're dealing with different types of sources. Number 1 is independent voltage source. Number 2 is dependent current source. And we have 2 amount of resistance. And we have 3 nodes, like I remember, A, B, C, and C will be the reference point. That means we don't have any different potential at this point. Alpha equal 5. We have 3 nodes, A, B, C. Let's make C be the reference node, VC equals 0. Now let's talk about here. It's not V total, that's wrong. That's here I total. I total equal IAC. Let me be sure. Yes, IAC plus IX. That means IAC plus IX equal alpha IX. And we can say, because all of these Kirchhoff laws equal 0, we can say IAC plus IX minus alpha IX equals 0. This Kirchhoff current law. From Ohm law, we will try to calculate the current by dealing with the different potential, by dealing with the voltage, I mean. Current at IAC equal different potential between AC divided on R1 and C, the voltage at C equals 0. That means IAC equals VA divided on R1. R1 equals 4. That means VA divided on 4. V total, let's put this result at the equation 2.11. I can remember, no. Put this result here instead of IAC will be VA divided on 4 plus IX minus alpha IX. Alpha, the author is given it to us. Now let's try to calculate IX after that. Equal 0, like equation 2.11. Like I said before, A, B, and at the last we have C nodes. Now let's work on IAB equal VAB divided on R2. Here, VIAB, it's the IX, it's the same. We can use all of them. Which one we want? IX, VA minus VB divided on R2, VG equal VB, and R2 equal 2 ohm, like the author said. VAB equal IX equal VA minus 1 divided on 2 ohm. Minus 1 volt divided on 2 ohm. Now we have 2 unknown elements, IX and VA. The author give it us VA equal 8 divided on 7. That's mean the old element, the unknown element is IX. Now, like I said, IX equal, that's mean 8 divided on 7 minus 1 divided on 2. equal 1 divided on 14. Here IAC, here IAC equal VAC, that's mean VA divided on R3, like I remember. No, we don't have resistance here. That's mean VAC equal VA divided on R1. AC, maybe that's AC. AC. It work from the side at the loop number 1. The loop number 1 reverse clockwise. R1 equal 4 ohm. Like that, yes, that's right. Divided on 4. VA, A divided on 7, divided on R1, 4 ohm equal 1 divided on 4 ampere. By the same meaning, the same trick, the same way, by use Ohm law, we can calculate the drop voltage here and the drop voltage here, because the volt drop equal current dot resistance. That means A current I AC dot 2 ohm will equal the voltage drop at resistance 2, and the current here, the voltage drop at R1 equal IAC dot R1. After that, we can calculate the power equal voltage current. Question 2 is done. Let's go to the last question today. As well, different from the last 2 examples. Here we have 3 different amounts of resistance, R1, R2, R3. We have 2 loops. We have here independent voltage source. Here we have dependent voltage source, VS and VG. All of these 2 loops with clockwise, we must calculate IY, that's mean IAB, and the voltage drop VY, or V2, the voltage drop at loop 2 at resistance 3. Let's keep going to solve. We will start from loop C1, Vx here equal 12 millivolts. From Ohm's law, V equal IR, Vs equal Ix dot R1. Just we have one resistance at loop 1. And after that, let's calculate IC1 equal Vs divided on R1. That's mean 2 milliampere. That's Ix. Now let's keep going to loop 2. Here, VAB plus V or minus, because here we will dealing with voltage drop. Let me be sure. Here, ABC, let me see. VAB plus VBC minus VG, or we can say VAB plus VBC, VAB plus VBC equal VG. And to make this line equal 0, we will say VAB plus VBC minus VG equals 0. Now let's work on VAB equal from Ohm law IR AB, or we can say R2. Let's put it here. IC2 or AB or R2. It's easier. R2, I will say. VAB equal to IC2. Now let's work on VBC. VBC equal IBC dot R3. Here, IBC dot R3 or IC2 R3. That's mean 98 IC2. VG, the author is given it to us, equal to 100 IX. Now let's put all of these results here to simplify this equation more. Now we have 3 unknown elements. 2 of them is IX. IX, like we said at this diagram, IX equal IC1, and we calculated IX here. Let me see, IC1 or IX equal 2 milliampere. That's great. That's mean here just we have one unknown. This unknown is IC2. Let's calculate it. It's equal 4 milliampere. Now VBC, because now we have IC2 and R3. VBC, let me be sure. VBC, yes. Let's calculate the voltage drop at VBC equal ABC or IC2 dot 98 ohm. IC2 equal VBC, sorry, equal 392 millivolts from ohm law. That's it. And by that we can calculate the power because we have all these results, the current results and the voltage results, and the power equation, like we know, equal voltage voltage dot the current. Equal power, its unit is the watt. That's it. Our lecture today is done. Thank you about your listening or watching. Maybe tomorrow we will try to complete the other solved examples, because we have many examples like that. Thank you about your watching, your patience and your watching. Have a good day. Maybe tomorrow I will try to solve another questions, have many resistance more than today. And we will focus more on the independent dependent sources.